So before we solve the problems 2, let us review the fundamental theorem of calculus 1. If we want to compute the definite integral from a to x of the function ft dt from, actually here t is from a to x here. There's a typo here. This function t is from to x. So for now, I'm gonna let you be the co-host, Gary. Then you can admit people to join the class. Is that okay?
Okay.
So that you can help me. Thank you. So let us continue. Here, t is from a to x. Suppose, hi Dylan. Suppose ft is the antiderivative of small ft. Here, right? Then the integral from a to x here will be, let me write it clear this way, integral from a to x of ft dt will be the antiderivative evaluate from t is equal to a to t is equal to x, right? Then we substitute the value of t is equal to x here, give us the function capital F of x minus capital F of a. Here, a is a value, a number, and if x is a variable, then capital F of x here becomes a function. So if it is a function, then we take the derivative of g of x, where g of x is this guy, right? So if we do so, then we see that it is the derivative of the guys here, f of x minus f of a, right? So this is the derivative of a difference. So what do we have here, Gary?
That would be just, it would just be, I'm sorry, give me 1 second.
Yeah, sure. Take your time.
This is for question D, correct?
Yes.
It would be the antiderivative of, what is this, secant t?
We haven't done it yet. We just review the fundamental theorem of calculus part 1 first. Then we apply to question D later. But look at this here. Now we're computing the derivative of f of x here minus f of a, right?
Mm-hmm.
This is the derivative of a sum from the properties of derivative. It will be the difference of the two things here, right?
Mm-hmm.
dx of f of x here, subtract d over dx of f of a, right? Is that okay?
Yes.
Then here f of a is a number, therefore the derivative of a number will give us 0, okay? And here, this guy, derivative of f with respect to x, give us small f here, right? Because capital F is the antiderivative of small f here. Therefore, we have this part 1 of fundamentals theorem of calculus. Now, we apply it to the question D. Okay, let us define I to be the integral from 1 to x to the 4th secant t dt, right? Okay. Look at this. In this form, what is the integrand, the function of this? If we call this guy is small f of t, right? So, therefore, I here, what do we have, Gary, from the fundamental theorem of calculus? Oh, from a previous computation here. Suppose we have here.
It would be the antiderivative of this, correct?
Yes. Suppose ft is the antiderivative of ft here. Then we have that I, the integral here from 1 to x to the 4th of ft dt will be capital F of t, and t will be from 1 to, what is it? Yes, x to the 4th. Then we evaluate the value of the upper limit first, right? And what do we have here?
It would be x to the 4th power.
Very good. Capital F of x to the 4th minus f of 1, right? And this is the antiderivative of this guy. So, and as we define that this is the function g of x, right? Or according to the notation of the problems, it is g of x. Therefore, we can compute the derivative of g of x. It would be the derivative of f x to the 4th minus f of 1 here, right? Is it okay?
That's good.
Yes, very good. Now, the same story. So d of this, it would be d over dx of f x to the 4th minus d over dx of f evaluate at 1. Again, this guy is simply a number. So it is 0, right? Furthermore, this guy, be careful, we need to use the chain rule. Okay? And what is it here in the chain rule? If you don't remember the chain rule, let us write it here. Suppose we let u is x to the 4th, right? Then the function f of x to the 4th is f of u. U is a function of x. Okay? Are you good with that, Dylan and Gary?
Yeah.
Okay, very good. Now our job is to compute d over dx of the function f of u of x, right? We just rewrite. Yeah, let me write it this way. X to the fourth is the same as d over dx of f of u sub x here. Now the chain rule tells us that, okay, d here, it would be d over du of f of u times du over dx. This is the chain rule. If you don't remember, this is how we do it. Okay? Here, what is, or we can write it, f prime u times du over dx, right? Another way to write it, or let us write it as u prime here. Okay? And we assume that capital F is the antiderivative of small f here. What does it mean? What is capital F prime here?
Wouldn't it just be F?
Yes, it is f of u, right?
Mm-hmm.
Here u prime. And now we replace the orum here. U is x to the fourth. It means that this we need to compute it in x variable. Okay? And u prime here will be x to the fourth because the question asks us to compute the derivative with respect to x. Therefore, we just need to use x variable here, right?
Mm-hmm.
So it will be f of x to the fourth here, multiplied, what is the derivative of x to the fourth here?
It'll be 4x
Very
cubed.
perfect. And as we define above, what is the function f of x here?
It is it's secant t.
Yeah. F of x is secant x here, right?
Mm-hmm.
So we know that f of x is secant, f of t is secant t, or whatever variable. So it means that f of x to the fourth will be secant of x to the fourth here, and multiply with the number here, right? 4x cubed. Or we can rewrite it to avoid confusion. This is 4x cubed times secant of x to the fourth. Okay?
Mm-hmm.
That's it. So therefore, this guy becomes secant x to the fourth. Oh yeah. Let us write it as 3x cubed. Okay?
It's supposed to be 4.
Oh, you're right. Thank you. Yeah. Thank you. Good job. So this is the question B. Right now, let us zoom it out to see the whole picture, right? In the test, you should, yeah. Or now we understand it already, right? You can do it fast. You can simply, okay, say that from the fundamental theorem of calculus, it will be the function integrand here, right? And we know the rule should multiply with the derivative of the bounds here, right?
Mm-hmm.
Or let me write it shorter. We understand it already, right? Now let us do it faster this way. Or another way to write the answer. We're given that g of x is integral from x to the fourth secant t dt. We want to compute d over dx of g of x, and from the fundamental theorem of calculus, it will be the fundamental theorem of calculus tell us that this function becomes the integrand with the variable is exactly the upper bound here, right?
The upper limit, yeah.
Yes, the limit. So we can write it faster. X to the fourth. And now we use the chain rule, right? The chain rule tells us that this is the secant prime of x to the fourth multiplied with x to the fourth prime. Therefore, secant, no. Wait. No, we cannot write it this way. It should be secant x of this, and we do it faster here. X to the fourth prime here. Yeah. Should write it this way. Okay. Yeah, that's it. Because here we assume that we understand the fundamental theorem well, and we can do it fast. And the detail is explained above. Okay, this is the shorter way to explain and still keep the logic. Well, is it okay?
Yes.
Very good. So we have just presented two ways to write the answer for these problems. Let us move on to another example here, right?
Mm-hmm.
Now, let us see. Let us do this one. Question C, okay?
Okay.
The question C here, from the fundamental theorem of calculus, d over dx of gx. So before doing this, let us define, let us determine the function f of t in the theorem, what it is, right? So what is the function, the integrand here? Do you get the question?
You're asking us for the...
So the f of t is the integrand, right? In our case, it is sine of pi.
Pi t squared divided by 2.
Very good. So we know the integrand here, right? And from the fundamental theorem of calculus, it tells us that, okay, derivative of this integral give us f of the upper limit here, right?
Mm-hmm.
Which is f of x. Now it means that fundamental theorem of calculus. It means now we need to replace and explicitly write the function down. So it would be sine of, what is it here?
It would be sine of x squared divided by
Yes.
2 times the derivative of x.
Yeah, that's it, right?
Mm.
So very good. Okay.
Okay.
Now let us do another one. That is the question C. Now let us do the question C, B here. So we can write it down in here, d over dx of g of x from the fundamental theorem of calculus. It gives us, what is it?
It would be square root. I'm sorry. It would be f of x equals what? Square root over 1 plus t squared.
Now, yeah, like this, right? Okay, f of t is square root of 1 plus t squared. And remember, the fundamental theorem of calculus tells us that it will be f of x, or in this case, it becomes this, okay?
Mm-hmm.
Very good, that's it. How about this one?
You want us to find ft? Or it would just be what? Cosine of 9x.
Yeah, that's it. Good job. Okay.
Okay. I'm
Now,
sorry, can you give me a second to like write all of this down?
sure.
Thank you.
You're welcome. Dylan, is it okay?
Yes, sir.
Very good.
Okay.
Let us continue, right?
Mm-hmm.
Now we've done B, C, D, A already. Now let us do the number E, right? So let us determine it clearly here. This is the function f of t here, okay? And the upper bound here is a function of x. Very well. So the fundamental theorem of calculus tells us that g of x, it will be of g prime of x, derivative of this integral will be the integrand, right? F of t, where we evaluate the function at t is equal to 10x. If we write it that way, it's not a logical way to write it, but right, we know that it is f of the upper bound here, right? Then f of 10x, okay? multiply with 10x derivative. Yeah, I know it is short. So let us write it as the antiderivative as we did before for the question D. I think it's easier to understand. Okay. Or are you good with this one? We just evaluate the function at the bounds here, right?
Mm-hmm.
And multiply with the derivative of the upper bound here, the chain rule.
Okay.
Does it? And here, f of t is t squared minus 3 ln t. In our case, we need to evaluate the function at f of 10x. So from this, what do we have here? What is f of 10x?
10x squared minus 3 ln 10x.
In the definition of the function f, the variable is t, right? But now we replace t by 10 of x.
So what is 10 times, well, not times, but 10 of what? T squared minus 3 ln t? Or,
Or in this case, it would be 10 squared, right?
okay.
Yeah, because here is t, the input square, right? And subtract 3 times the ln of the input. And the input in this case is
3, it'll be t squared.
10x.
Oh, 10x, I'm sorry.
They play the similar role, just different notation. Now, what is the derivative of 10x here? If you don't remember, double check the antiderivative table, the derivative table. You see derivative of 10x is secant squared. Okay?
Mm-hmm.
And that's it for the fundamental theorem of calculus. Do you have any question?
No, sir.
Yes. So what is it?
Oh, no, I said no. I didn't have.
Sorry. Okay, very good. Then, or you can do the question E as I explained in D. Write it in more details. It's up to you, the way we did here, right? So, but it will end up this result. Now, let us evaluate these definite and indefinite integrals. But before doing that, let me